Hello everyone, hello Delphi community. Today's our topic together with Ian Barker. I think you know this very famous guy because he's like of course Embarcadero MVP, popular and famous Delphi developer, author of different articles, presenter of webinars and so on. As I said, our today's topic is about IoT, which stands for Internet of Things. Why did we choose the subject? Because last 10 years, from year to year, it's like a trend in software development, in again, like devices, our life in common, because right now we have a lot of different things and devices around us. And today we want to just explain to our community where is it in common. It's like the first part, and the second part, Ian will present for us practical examples. Ian,
yes,
what do you want to add to this intro?
Yeah, nothing really. And if I'm popular and famous, then that's good. But I think infamous is the other word. I do get everywhere a lot. I talk a lot.
If you guys open welcome page, at least for the last, I guess, 10, 20 videos, Ian will be there.
Yeah, I am everywhere. That's true. Jim and I work together quite closely to try and promote Delphi. He has too much work on. Jim McKeith, this is. And so I kind of help out with that. I think it's about using your skills, and my skills are to do with talking really and presentation. So that's cool.
Yes. Okay. Also, what I want to add is this: our subject will be for two types of, let's say, layers in the business. The first one, as we said, we want to show the possibilities of Delphi, that it's totally adopted for IoT, and we can do everything using Delphi and C++ Builder for IoT solutions. It just like give you facts. And the second part is much more technical, maybe for developers, where we will show real devices and real implementations.
Correct.
And Ian, in simple words, maybe for the guy who just heard something about this term, where is it?
What is IoT? Well, IoT literally means Internet of Things, and I think they chose that term because a thing attached to the internet could be anything, and it could be as simple as your cell phone connected and doing things. I mean, that's kind of an internet device, but really that's more like a computer. But all the other devices are things like central heating controllers for your house, lawn sprinklers to sprinkle water. It could be a fuel measuring device on a truck or in a factory. It could be some process managing stuff. So it could be weighing out the ingredients on a assembly line or a food packaging line. It's anything that is a device that has an internet connection and can be controlled via the internet. That's really what it is. So it's as simple as that.
And I want to add why we did not have such a term for instance 30 years ago, because we have a revolution in batteries. Of course, the second one is like a popularity of internet. That we right now we have internet everywhere. I think that's why we can connect each like small device. This device can be alive without any power supply. And it can be connected to internet or to another devices which can be connected to the internet.
And in fact, the term Internet of Things is not very accurate, because it really just means devices that have got specific purposes that are connected in some way to some other devices. And as you quite rightly pointed out, that could mean it's on a network in a building and never gets to go out on the internet. And that happens quite a lot, but it could more often than not mean that it's, you know, in some kind of far off office, a device there that you're looking at. And in the case of the speciality I have, that could be a time recorder where people are clocking in and out for work and opening the door via a relay. And back in the head office, someone is working out if you were late for work. So that's the kind of uses that are there.
Yeah. And we have a lot of popular terms like smart home, smart even city, smart city, when we can cover the city using some devices, and these devices will measure like temperature, humidity, traffic jams, broadcast internet, a lot of things. And all these devices will be connected to each other, and it's called smart city. And important add-on that we have a lot of information for the system. And I think that's very, very crucial, provide and create and implement, let's say, like channels, how these devices will exchange information between each other and like central server, if we even have central server, because the system can be dedicated without even maybe some central server.
Sure.
So if we will talk about yes, because you already mentioned about a little bit technical things, how it can be built, because you also mentioned that maybe the device won't be connected to the internet. In this case, from the satellite view, how it can be built.
Yeah, I think the easiest way to answer that is maybe to actually see some devices and explain what those devices have in terms of capability. So what I have over on my desk here, which I will bring over, are a few different devices. Okay, and I'm going to show them on this camera here because it's clearer, but I have actually got it set up over there so that you can see. So an Internet of Things device could be as simple as this. Okay, now this might show up okay on a webinar, it just depends. And what this is a device called a Shelly 1PM device. And I have a, if I share my screen, let me just do that now. Let's see.
Yes, and I want to mention that we do not have some specified list of devices. Everything can be like a part of Internet of Things. We will just show a couple of examples which can be used in real life.
Yeah, so this is one device, which is the Shelly 1PM. And what that is a small device. It's very, very small. It's literally fits inside my hand and I can hide it. If I hold it up to the camera, you can't see it. And it has got some power entry things in there so that you can apply power to it. And it's got some relays. So if you can see where my cursor is pointing at the moment, here's the power that goes in, and then there's a little relay switch in there. And what that allows you to do is turn on or turn off something in your house. It's an amazing little device because it's got a web server built in, and also there's an internet app that comes with it. So at the basic level, this is a kind of a smart home device or a smart factory device. You could use this to turn on your toaster, or you could turn on, you know, a sprinkler outside in your house. They actually even have a routine for this device that will control roller shutters. So like a garage door or a security shutter at the front of a house or a factory or something like that. And the way that works is they have an app like this in the cloud. I'm actually connected to it locally. This is my local IP address here. And what it allows me to do is to go into the device and do things like turn off and on a relay. And all that is doing is sending a message down to that little device that I just showed you and telling it to turn off and on. It is connected to the internet as well. So if I go to, where are they? Yeah, I can't remember where it is, but there's some information that shows you what internet. Oh, here we go. What internet connections there are and whether I can.
By the way, does it have built-in Wi-Fi module?
Yes, it is actually connected to Wi-Fi, and in fact, right now, it is actually connected to my network, which is called Scary Potato, because I think that's my favorite name I've ever given it. My stepfather is Polish, and as you know, Polish people like potatoes for using for vodka, and that's the best vodka you can get, but in my opinion. But Scary Potato is my Wi-Fi, and that's all I needed to do was connect to the Wi-Fi, just like any other, you know, mobile phone or anything like that. Put in the password and it connected. Once it's connected, this particular device will connect to this cloud. Now, the cloud itself allows you to have things like URLs for a web page. So what I could do is create my own web page and have a URL in there that is a REST endpoint or something like that. And when the button is clicked on here, what would happen is it would trigger the URL and make something happen on a website somewhere. But you could have the opposite. You could have a web page that actually switched off the device as well. So the relay on the device could be switched off using the URL. Now, that's not very Delphi centric, but you could write a Delphi program to trigger URLs and receive URLs. You could actually, instead of having a URL to a website, that could be your local Delphi service or application that you've written, and it receives, it opens up a little web server and receives the URL. So that's one device. The other type of device.
By the way, I have a question.
Sure.
What about, if we are talking about the relay, what about the button? Which button do we have on this device?
No, the button is actually a virtual button. There's nothing. Okay. Yeah, there's actually nothing on the device itself. That's literally what you get, is that little box like that.
Okay. Yes. No, for our listeners and watchers, let's say that we have a device and we have to like put this device in the middle of some wire, and if necessary, we will turn on power supply or turn off, and for example, our garage door will be opened or closed.
Yeah,
but
and in fact, the device includes the ability to have a switched power supply, and it also, when I go into my cloud application here and click on the button there, it will actually then turn the relay, this part of it, on and off. So that's the idea, that it's a cloud-enabled button.
And we can implement our own application, for instance, where we will communicate directly with this device or via some cloud of this Shelly 1PM.
Yeah, and it also allows you to, it knows the voltage that's going through. And the reason that's useful is if you've got a device that might draw too much voltage, you can actually detect whether the voltage is too low or too high. So if you had a battery supply linked to it or something like that, it could detect when the power was turned off. And then you could ring an alarm to say, hey, my server's offline or something like that, because there's been a power cut. The problem is you need to have some form of power supply to make this still work. But that's one of those little things. But anyway, that's just one of those devices. Now,
one more thing. We started just from technologies in common. In this device, what we use, we just have Wi-Fi connection with internet, and we are using REST API server. It's like a request answer. Do we have some another like MQTT or WebSocket transport here?
Yes, it supports MQTT. Let me go to here.
Now, for instance, if we press a virtual button, how this device will know that we press the button?
Because in the cloud, it's actually sending messages down to it. But if you're using but if you're using MQTT, which you can do in
yes, I just want to provide common information for the watchers. Like in this case, we have also such technology which called MQTT, which, by the way, built over the TCP/IP. When our device have, let's say, a live connection to some server, and it's not like we have for REST API service, when we just perform request HTTP and we get answer. In this case, once our device establish connections to the server, it's MQTT connection one time, and then it can leave a channel and it waits some packets of data from the server, and that's it's a solution which we can. Why do we have at Load this IoT? Because we have such solution.
Yeah, and in fact, I'm going to show a working MQTT example in a moment. With this device, there is an API, and the API explains how everything works at a basic level. So with the Shelly 1PM, it says, if you do this, then this will happen. If you do this, then this will happen. So you can connect via HTTP to the device, or you can connect via WebSockets, which is another technology for people watching, or you can connect via MQTT.
And I also want to add that even 20 years ago, we had just regular TCP IP connections using Delphi, Windows, and so on. But together with IoT, we have these two protocols, WebSocket and MQTT, and they were adopted for unstable connections for internet and between other devices. That's the difference. Yeah.
Yeah, and in particular, MQTT is designed to have the concept of a quality of service, which we'll talk about when we do the MQTT example. But you can actually get it to repeatedly send messages to a device until that device answers. So it will keep going until the device comes back and says, "Okay, I heard you," because some of these connections might be very shaky.
Yes, but we are saving also battery and the power with all this IoT MQTT, because in case of like a regular REST API, just request answer, we all the time have to spend energy for calculation, like computing resources. Here we just wait.
Correct. Yeah. And so anyway, I don't want to talk too long about this particular device, but it's just an example, a typical example of the sort of devices you can get. Now, looking at some other devices, this is a device that I actually have here with me now as well. You can see it on the screen share. If I go back to wherever I can stop sharing, just 1 second. Yeah, hang on. Always the same with Zoom, isn't it? This is why we have, oh, here we go. Stop sharing that. I knew it was somewhere. I have 3 screens like everybody else. I can never see the controls. So if we go back to the devices, so here's my keys, okay, which you should be able to see. And on my key, I have this particular device that I just showed a second ago, okay. And this is what's known as a Bluetooth low energy tag. So we didn't talk about the ways of connecting initially. We did say you can connect via the internet, and that's Wi-Fi or Ethernet. And you can connect directly across a network, and that's usually a similar thing, or it might be RS-232 or RS-485. And another technology is Bluetooth Low Energy, which is one of these little tags. So as you can see, my car keys, they're not that big, they're just regular car keys. And on there is this device here, okay? And that's the one that I just showed for a second. So what I'm going to do is just show a share my screen again, but this time I'm going to show you my, let's see, this one here. You should now see my Delphi application. Okay, so what this device does is quite interesting. So you should be able to see the Bluetooth energy beacon. I got this one from a company called Blue Charm. I have no connection with any of the companies we're talking about today, and neither does Sergey as well. So you know, we're not
yeah, we're not promoting any company.
No, nobody's paying us yet. so we've done something wrong there. We've obviously not managed to do what we need. So you should be able to see my screen and what that device is. Now, this device is about $14, which obviously to Americans is not too expensive. A little bit more expensive if you're over in India or, you know, Russia or Poland or somewhere like that. It just depends on the cost of living. These devices are quite common now, Bluetooth Low Energy. And in fact, my car, for my car insurance, has a little Bluetooth Low Energy tag that I have to keep inside here. And I have an application on my cell phone that tracks my driving. So if I brake too hard, or I go too fast, or I turn a corner too quickly, it scores me on my driving. If I get a good score, a high score, then I get a discount on my insurance. If unfortunately my daughter is also on our insurance as well, and she's 22 and she drives like a maniac, so it knows she's driving badly, or should I say not as carefully as she could, and she won't get the same discount. So these Bluetooth energy low energy devices are used for tagging, and it could be to know where your keys are. This one's multifunctional. It has got the ability to have a button here that triggers a message in Bluetooth low energy, and it also has got a motion sensor. Now, what does that do? Well, when you connect to a Bluetooth low energy device, you will get a message coming back at a regular interval, being sent back to you on regular intervals. And that Bluetooth low energy message contains some packets of information. In the case of this device, it is the ID of the device, the power, whether the battery is running out, and any information I've encoded in it, like the name of the device. I might have given it a special name. But this one will also say whether I've pressed the button and whether it's moving or not. When if it has moved, it sends another.
We are not talking about any GPS or here. Just move. Like somebody just moved, like for instance, for security purposes, we can use.
Yeah.
Right?
So if I pick my keys up and someone, I leave them somewhere, it knows I moved my keys, and can send a little message out to say, hey, someone stole your keys or whatever. But it's used for a number of different things. One of the things I've seen an application for, it's on the Embarcadero blog, someone used it in a museum. You would download an app on your phone, and it's written in Delphi, and you would walk around the museum, and it would detect the Bluetooth energy beacons next to the exhibits. So if you went next to the exhibit of a dinosaur, it would actually show you all the information about that dinosaur and give you web pages where you can go to find more details, like how long ago it ate, and all these kind of things. That's a very good use of it.
Can I add something also?
Yeah,
because
sure.
they became, I guess, so popular. If you remember when the iBeacons were introduced by Apple, and yes, it was after. Of course, we have to mention the Bluetooth energy started from, as I remember, for Bluetooth low energy started from 4.4, something like this version of Bluetooth. And that's why, again, we can save a lot of batteries. Can save batteries power. That's why, again, this became so popular. And if we have such beacon, yes, is just something which like broadcast information around it, and we even can have a system of the beacons. And if we have this system like 3 or 5 beacons, we can detect position of your beacon inside the system using such technology which is called triangulation. Because each beacon measures signal from another beacon, and that's why we can using mathematical calculations detect this distance.
Yeah, exactly. And that's what it's used for, is positioning and locating things. It's almost like a location beacon. Bluetooth low energy is more complicated than that. It allows you to do all sorts of communications, but these tags are more really about, here I am and this is my information. So it allows you to, you could use it in a company. If you're a security guard and you have a security guard company, for example, you want to know that your security guard has gone and visited all of the spots that he should do. So he's gone to look at the back door, he's gone to check the main office, he's gone to check, the warehouse or whatever, or she has gone to do that. And what you can do is position one of these Bluetooth low energy beacons around the building and plot where your security guard is, and make sure that the security guard has done what they're supposed to and visited all the important security points at the time you wanted them to. I've seen it used for that. That's called a guard tour, and it's quite popular in the time and attendance and human resources kind of industry, for making sure that people are where they're supposed to be. You can do the same thing. You could put a Bluetooth low energy beacon on a rack in a warehouse, and then have a scanner on a like a Windows tablet or a mobile device, like an Android device or something like that, on a forklift truck. And then as the forklift truck drives around, you can tell where the forklift truck is. So that if the driver gets off and parks the forklift truck, you can find out where that forklift truck is because it reports back to where it is. So that's what it is. If I just, because we're short
also I want to mention that the beacons are not for, you cannot put this beacon to the back of your kid and he will go to the school, because we should have a receiver which should be close to our beacon. It's usually from, let's say, from 1 meter to up to 20 meters. It depends of the walls surrounding and so on. That's why it's not the Wi-Fi. Yeah.
Actually, this device is a long-range one, and can actually go up to something like 600 meters. So it's pretty powerful.
Yeah, it's good. But it also depends on the receiver. But also, I have such an example which we had before. We developed authority like authentication provider, which in the pocket of the employee, and when this employee comes to the room, computer via Windows, authentication provider will be able to unlock in like password plus beacon.
Yeah. The only problem with that kind of technology is that it authenticates the device. So in the case of this tag, what it's doing is saying this tag is near my machine, therefore this tag allows that machine to open, which is fine. But also sometimes you want to have some, every so often ask them to type in a password as well, because otherwise if I steal this tag, your tag, now to any machine that's locked using that tag, it thinks I'm you. So it authenticates the device, not necessarily the user, which is why when we do this, what we do is every random interval, it could be like 10 goes or 4 goes or whatever, it will actually go, hi, I know it's you, prove it's you. Because, and actually with the biometric devices that we sell, the reason that you might use biometric, even though like fingerprint recognition and face recognition can be a little bit tricky, is that when you're using biometrics, you're authenticating the person and not the device. And so it's a very useful thing, and it does save people remembering or forgetting passwords, but it's very important they don't lose their tags. So if they're using a tag, that tag needs to physically be attached to them, in my opinion. So on a key tag, like a chain, a stretchy chain or something like that, or just kept in their wallet, because most people are very careful not to lose their wallet. So unless they're unlucky. So very briefly, if we just show how to talk to one of these devices, if you've installed the samples in Delphi and go to the samples directory, there is a sample called the Bluetooth low energy device sample. And if I just run this now, which you should be able to see on your screen, hopefully, you'll get a little app like this. It's not very glamorous, but it does work. If I now click on Start Discovery, after a couple of seconds, all being well, because I have been fiddling with these tags, so I might have broken it, then it finds a tag. And so this particular tag is that it's found is actually not this one, fun enough, but it's called Alt-B, and there's the serial number and how far away it is. This particular tag that it's finding, there's a building site over the road from me where they're doing some building, and they have their equipment tagged with Bluetooth tags. And I keep finding their tags. So this particular one is 223 meters that way into the distance on a tag. My tag will show up eventually, but we're not going to bother too much. All you need to know is that's what the tags look like. Here's an app that will run it, because we're going to talk about some more interesting things in Bluetooth. But Bluetooth is great, but it can be a little bit what's the word I'm looking for? Unreliable sometimes. That's the only thing. Sometimes,
especially if we are talking about distance, because this RTTY signal, sometimes it's just, I don't know, like randomizing.
Yeah, and also there's different types of Bluetooth low energy. So there's things like I forget what the technology is now. I should pull that page up again because I just had it. But there is a Eddystone, that's it. Eddystone URL allows you to broadcast a URL from the Bluetooth tag, and that is actually an Apple technology, and Apple and Google withdrew it. And I think the reason they withdrew it is they didn't want people being virused, shall we say, or sent to a random website. I think they made it so that you had to okay the URL before it went, you know, your browser on your phone went to it. But for whatever reason, they removed it. So I'm guessing there were some issues with it. So that's that. The other thing
can you a little bit more explain about this example? Because okay, we have a Bluetooth low energy device.
Yeah.
Using Delphi, do we need any existing SDK, or we can use just generic Bluetooth components from Delphi and we can connect to the device?
Yeah, it's a good point. And what can you use? Well, on this particular system, everything that it's doing is built in. Okay, so there is a T Bluetooth LE device, and that is built into Delphi. And all you need to do is to include the Bluetooth system.bluetooth, which is this unit here. And then that will give you a Bluetooth device. Now, the beacon device has got some additional things put into the example in the record, so that when it discovers a device, it can get back some of that information in a kind of nicely managed way. But actually, in order to use it, all you need to do is include that system.bluetooth, and off it goes. I don't use Bluetooth very often, so I don't claim to be an expert on it. But Delphi is very well served with the ability to manage and communicate over Bluetooth. You can do things like create connections that are continuous connections over Bluetooth. So, for example, if you've got like a blood pressure sensor or a blood sugar sensor or something like that, and it only uses Bluetooth, you can actually make connections to the device like that. Those sensors normally have very good battery power, and then you can receive information from the device. My brother-in-law is a doctor, and his eldest daughter is a type 1 diabetic, and they have a little diabetic insulin pump, and this is the same as Scott Hanselman from Microsoft. He's also a type 1 diabetic, and he also has the same insulin pump. What they do is they have a little program that they wrote. Actually, it was an example to do it, although Scott Hanselman wrote his own, and it communicates with that device and constantly monitors your blood sugar, so that when your blood sugar goes too low, it emits a warning and warns you that you could be about to have a medical episode. So that is all easily doable in Delphi without anything extra. You don't have to go out and buy a new library or pay any money. As long as you've got Delphi, you're good to go.
Yeah, but I also want to add that it's a bit about beacon, but our Bluetooth device can have on the board, it's called get server. Mm-hmm. Get server, it's let's say again like a framework, I don't know. It's like it's interface for your Bluetooth device, which suggests for you different channels. It means that you can connect to your device and make some subscription on which services do you have. For example, we have a device and our application will tell ask him to get you, okay, we will have a channel for the temperature. I subscribed to temperature channel. I have subscribed to the channel, and I will receive information from time to time. And we can have different custom channels with totally different information. As you mentioned, it can be from medicine, transportation, and so on. And I want to just add and explain some possibility of Delphi. If this device will go with its common and custom SDK, usually you maybe won't know, let's say, low-level explanation of the protocol. For instance, you will have a binary packet, but you don't understand which bytes represent which information for you, because producer provide for you SDK. It can be like Java library or iOS library. And even using Delphi, using FireMonkey, we can take this native Java, like Android or iOS library, using description of our SDK, like paper from the vendor, we can create bridge and wrapper path files where we just explain and map the methods from the SDK. And after that, we will use these methods from Delphi Object Pascal code, which will work like map methods from the Java or iOS library. That's also possible, guys. And that's what I wanted to add.
Yeah. So when you're talking about publish and subscribe technologies, the most common ones of those that are used across the internet rather than Bluetooth are MQTT and Stomp. And they're very, very similar. They both can work over WebSockets and other things as well. And I'm going to show a demonstration of that in a second, which leads us nicely into the next thing I'm going to show. So I think we've covered Bluetooth beacons quite effectively. Let's talk about something else. My light is blinding me, so let me just close all that so I can see a bit better. So if we stop sharing again and go back to my camera, the big thing that really happened with internet devices, I'm going to bring this over. I was going to use my other camera, but I'm not going to do that right now, is something like this, okay? And what this is a thing called an Arduino. And if you've not heard of an Arduino, then you really need to look it up. But it includes a board that's literally, this is still in the packet, but it's a circuit board that kind of looks a bit like this kind of thing. And it's a computer on a chip. Lots of you, I'm sure, know about the Raspberry Pi, which is a very popular mini computer. The Arduino is as powerful and probably more powerful. It's expressly designed for Internet of Things applications. And in fact, if I was to show you that this is a similar kind of device, which has got a embedded Arduino in it. And what that is just a single board computer that runs on Internet of Things kind of protocols, okay? And this particular one's kind of cool. I'll show you it in a minute. But what it allows you to do is to have some applications written in a C programming language or Python, and it's got a nice cool display on it that's multicolor, and it's also got a temperature sensor. It's got a load of buttons across here. It's got a little multi-position button here, and it's also got some USB-C connections and stuff like that. This whole thing is capable of running any application you could ever want on the Internet of Things. This costs, I think, about $30 US. Which is not a lot really for a whole computer that can control anything you wanted. So that's that. This Arduino kit, as you can see, without me dropping it everywhere, this again is about $40, I think, and it's got everything in it. It's got all breadboard wires and stuff like that. So it's kind of cool. You can, there's a temperature sensor, there's a moisture sensor. I can make it detect if I've watered my plants enough and all sorts of crazy things like that. But the one device I am going to show you now is this one, okay? And this is kind of cool, okay? So what this is, if I just put my thumb next to it, you can see exactly, whoops, how small it is. It is literally smaller than my thumb, okay? And that is an Arduino device. And
does it have a gyroscope on the board? No.
It's got a little display on it, and if I press the buttons, it will cycle through various things. This is their factory demo that I've loaded, but as you can see, it's got its own LCD and it's got a gyroscope on it. So as I move that around, you can just about see that the rectangle.
Yeah, that's why I ask. It's like a gyroscope. Yeah.
Yeah, it's cool, huh? It's a very cool little thing. Now this is called M5C. Let's see if I can find it. It's an M5StickC. If I share my screen, because I'm going to show you some cool things how to program it. Let's go into here. Share the screen. So you should be able to see my screen now. And if I just pull this over.
You usually can buy these devices from Amazon? Or
I actually bought, I bought mine from Amazon. And I think I ordered it and it came like within 2 days or something like that. This is the device. You can go to M5StickC.com, which is at the top there, but we'll publish some URLs later. I'm sure you can put them out on your blog or something like that. But this is the device itself. If I, hopefully this will show up on the screen. Come on. Oh, there you go. So this will give you some of the idea of what this device has got. It's absolutely amazing. And all of these devices I'm showing you are programmed in the same way using the Arduino IDE, but we can talk to them in Delphi. So this has got a magnet, so it can stick to your screen or to the wall or something else. It's got an infrared transmitter, and it can actually transmit infrared flashes, and you can turn people's TVs over and really bug them. It's got a color LCD, power switches, multiple buttons. It's got 3 buttons. It's powered and programmed via USB-C. It's got some sensors that are Grove compatible. If you know about IoT devices, then Grove is a big sensor manufacturer. And it's literally the size of your thumb. It costs around about $15 or $16, I think, US. So very economical. Whether it's practical for an end user application, I'm not sure, because obviously it's got these stickers on the back, and you might not want your end users to see that, but they do a bare bones one without that case on, and you could, you know, if you're into 3D printing, you could probably print it. But if I just close this browser, I'm going to show you what we do with it. So at the moment, it's running, as I showed you, the factory default application. Okay, and what we do to program this is we use Arduino IDE. Okay, so if I open up the Arduino IDE, it takes a little second. I probably should have done that before. So here is the factory default app. I'll just show my eyes so I can see. Yeah, so this is the factory default app, and as you can see, it's basically a C program, and you know it exercises all the functions of it. I've actually written another program which I've called MQT. No. Oh, let me just pull it up. MQTT example. Yeah, here we go. So I've written a little program called MQTT example. And if I load it over here, like this, what this is it's going to use a technology called MQTT. Okay, which is a type of publish and subscribe technology that you talked about. Anybody can use it. It's very well discussed on the internet, and I've got some links later that we can talk to go and see where there's some Delphi examples. But this is all Arduino language, which is C, and it's embedded C. And it's actually not very difficult. If you look down here, you can see there isn't that much code really. But all this does is this will connect to my Wi-Fi. And I've hidden my credentials so people can't see my Wi-Fi password. I've done these presentations before where people go, "Oh, I spotted your password," and write it down. And it subscribes.
In case if you use the same password for your bank account.
Yeah. It's not the first time I've done something like that. Now, what MQTT is MQTT has a thing called a broker somewhere out on the internet or in your network. Okay, and all it's listening for is a type of message that says subscribe. Okay, so you subscribe to a channel, and in this case, my channel that I'm going to create is called Delphi IoT, which is this line here. Then once you're subscribed to that channel, you will get messages from anybody else who is subscribed to that channel. Okay, now the default is no authentication, so anybody could subscribe to this. But you can put authentication.
Usually you can implement your own authentication.
Yes, and in fact,
subscription. Yeah.
And the public brokers, most of these public brokers like mosquito.org and all the rest of it, they all have the ability to put passwords in and stuff like that, but we're not going to do that because we're going to demo it. Now, once you're subscribed to the channel, you have the idea of topics, and those topics could be something like an event. You might have a topic you call events. So you subscribe to the Delphi IoT channel, and then in there's a topic called events, and you might post a message in the events channel that says something like machine turned on, machine turned off, button pressed, or something like that. And that's what this little device does. So what I'm going to do is I'm going to send that down to the device and just make sure I've got everything set up. So I need to just pick the right one, which is this plus, like this. And then I just need to tell it which port, which is COM6. It says it's going to work. And then I hit this button. What you can't see very well down the bottom here, and we'll probably edit this bit out later, is that it's compiling down here this sketch. Not as fast as Delphi, which is one of the fastest compilers in the world. Aha, that's all I can say. But it will take a couple of seconds, but whilst it's doing that, eventually it will send some things down to the device. While it's doing that, let's go on to my corresponding program. So I've written a program that will talk to this device, and I've called it MQTT chat. The reason I've called it that is I've actually pinched some of the ideas from TMS, who are, as you know, a tech partner. Very good company, got a lot of respect for them, use their products and everything. So quick plug for them. I'm actually going to use, for the sake of ease, their MQTT client, okay, which is a very cost-effective MQTT client. This is where it is at TMS Software. And what this does is allows you to talk to servers and devices that implement the MQTT protocol, a little chat going backwards and forwards, as I said. And you just drop this component on your form, or just include it. You don't need to actually have a physical component. When you do that, it will work in later versions of Delphi on any platform. So this app is a FireMonkey app. I'm not going to do it because I haven't got it set up, but it could be working on Windows, it could be working on Android, it could be iOS, it could be Mac OS out of the box. Okay, and what this does, if I do that on there, is send some information backwards and forwards. So I'm going to show that in a moment when it's working. Let's go back to the Arduino and see whether the IDE has finished. I sent it down. Okay, and it has. Right. So if I get my Arduino device and turn my camera back on temporarily, and what we have here, you probably aren't going to be able to see this because of the way that cameras focus on colors. But what it's doing in the background is it is sending messages backwards and forwards to an MQTT broker. Okay, it's never going to show up. I'll send a screenshot of this later so that you can include that, or a video. And what that's doing is it
sends some messages to all subscribed devices
on that channel.
Doesn't matter.
Yeah, okay. And the actual channel that it's connecting to is let's just go and see, test.mosquito.org. Okay, so I'm going to share my screen again, just so we can go back to doing that and share. And so, as you can see here, I'm just going to scroll this up so it's easier for people to see. Where is it? Here. So, zoom my font up. So this is called a broker, okay? And this is the glue, the server in the middle, okay, that connects, that your device connects to and you connect to. When you both connect to that, you then subscribe to a channel. Now I've set a channel up called Delphi IoT, and because Mosquito is open to anybody, I don't need to do anything to authenticate against it. As long as I know the name of the server and I know the name of the channel, I can subscribe to it. So my little device is banging away in the background there. And if I now run my app, okay, what you'll start seeing is messages from my IoT device. Okay, so what you're seeing on the screen there is a message from this little device. Now you can see it's battery powered, it's connected to my Wi-Fi, okay, and it's sending that. Now what I've done is on this device, just down at the bottom there, which you can just about see. Oh, in fact, actually, if I hold it closer, you can see that.
It's in focus to you.
Yeah. You can see at the bottom of the device. Come on, there you go. There's a button. Okay, that where that little imprint is, right at the very end there. Okay, no, very end there. Okay, if I press that button, okay, you can see that my Delphi app is now saying button pressed. So that beeping sound is from Windows.
Sure, I can hear.
Yeah, and you can also see that on the message on there, it's saying button press. Now that is absolutely incredible, really, that this tiny little device can do that. Now this is only a very small part of the functionality of what this device can do, because I could be sending back gyroscope messages, I could be sending back temperature or humidity messages, but all of this is working in Delphi across the internet through this little device and connecting up to it. Now this could have a door relay sensor on here. This could be a homemade alarm. I could make my own alarm system if I wanted to. This could be a motion sensor, because there are motion sensors that are very, very cheap, like a few dollars, and they will detect motions. There is one version of this device that actually has a camera built into it with machine learning built into the board that will recognize humans. And so what you can do is get it to say, when someone walks into the room, it can recognize that person, and then you could send a message back via MQTT saying, Ian just walked into the office. Now, again, it's very low amount of money for what it's doing. It's under $100. In fact, all of these versions of these devices are under $50 US, and most of them are under $20 US. So they're actually very, very cost effective. And as you can see, it's still cracking away in the background. It's still sending messages. Now, if I close this, let's just look at what that program does.
And I think it also can broadcast for you battery level, and after that you can be notified that you have to change the battery in this device.
Yeah, it could be anything. I mean, the Arduino program that I wrote is fairly straightforward. So if we just look again at what the Arduino app is doing, oh, come on. This is a problem with Windows 11. I have my taskbar is in the way. There you go. Yeah. So this is the Arduino app. So it's connecting to that channel, and then it's connecting to the topic called Delphi IoT topic. A little bit of setting up so that it sets the screen on the little device. And then when Arduino runs, it runs in a loop. Okay, so the main part of the code is this loop. It's a bit like a main function in C, or actually just the application loop in Delphi. And what it looks for is, was there a button pressed? Okay, so this line here is checking to see if a button was pressed. If the button was pressed and the button was button A, then I send a message saying button was pressed. Okay, the rest of the time it's just sending out a message saying every 3 seconds is going to publish a message to that topic saying a message from hello from the internet device, and then a countdown. So if we just go back and watch, what that means is it will subscribe, and then every so often you're receiving that message from the Arduino. Okay, so that's simple on the Arduino. Now, what does the Delphi app do? Well, first of all, I have got this TMS MQTT client on my machine. There are no sort of complicated events or anything like that. The only 2 events are connect status change, because MQTT may disconnect. It is fault tolerant and can go faulty, and public servers in particular, the ones that are being used heavily for testing, like we're using Mosquito, can disconnect you because they're trying to preserve the resources. The other event is published received. And what that means is I've got a message back from the MQTT server. I look at the what the payload is. I convert that to a string. Okay, and I've received a message. The topic that it was received on, as you saw earlier on, is that little topic, Delphi IoT. And then if that message contains the word button was pressed, then I make a beep and I add the word beep to it. So just to go back to that app so we can see it again, side by side. Here's the message being received. It's received the message and it's saying it's what topic it's subscribed to. And if I just press the button on my device again, there's your beep. So it says, the message was button pressed and I beep. Very simple. Now that is the bare bones for someone writing an app that could communicate with one of these devices. Now, the fact I'm using this device is neither here nor there, because it could be any one of these devices, because with Arduino, one of the main strengths of Arduino is the amount of devices that there could be. If I go to the board, these are just the boards that I personally have, so M5StickC and Arduino AVR and all the rest of it. But there are many, many other boards. There are hundreds and hundreds and hundreds of Arduino compatible boards. The chip inside is open source on the BIOS, and that means that loads of people have gone away and gone, hey, let's go make some money making one of these boards. And there are thousands of them. And they vary in price and they vary in quality, but most of them are actually pretty good. The good thing about the competition of that system is that you can always get another board that's better, and there's enough people that complain about it, So that's it. So I think I'll stop sharing now. There are some other articles that I want to show people just whilst we're on. If they go to the Embarcadero blog, okay, the URL up here is blogs.embarcadero.com/?s=IoT, and we'll publish that later. And what that is, that will give you a search of all the IoT articles on Embarcadero blog. There are also some articles about specific technologies. This one is about Stomp. And I've personally written an article about Stomp as well, which is a bit like MQTT and works slightly differently. The only thing about Stomp is that most of the components to do that are commercial and they're quite expensive. Whereas the MQTT ones, there are a few cheaper ones or open source ones. I wrote an article about it as well on the blog. So again, if you go there, it explains in more detail than we're able to do today about how Stomp works and what you can do with it. And the same with some of the other technologies we mentioned, like WebSockets. What are WebSockets? How do they work? And if you go to my author page on the Embarcadero blog, you'll actually find lots of articles about things like there's somebody called Serge. Okay, and yeah, you're famous too. And lots of articles about various technologies, IoT technologies, and stuff like that. Oops, that's my wife messaging me for some reason. The thing about IoT is not so much how hard it is to get into, because it can be a little bit difficult. It's more a case of understanding what you're capable of doing in IoT, and then coming up with an idea for it to work. And there are so many possibilities that's the difficulty. There are so many things you can do with Delphi and IoT that actually, you're not really limited. And this is, as you know, being an MVP like myself and a tech partner, Delphi is usually the answer for most things, and it makes things easy. I'm lazy. I keep saying this every webinar I do. I'm quite a lazy programmer. I don't like to work hard. And the thing I like about Delphi is, look at the small amount of code to do what I want there. It's tiny. Now, the program itself has got hundreds of thousands of lines of code in the background, but that's all the power of Delphi's framework, the runtime library, the components, all that is hidden from me. I only do a little bit of code in here to make MQTT work. And the same with WebSockets, the same with anything else. you know, it's not difficult. Now, the Arduino stuff, there's a bit of a learning curve for that because it can be a little bit tricky. And if you're not used to C, then it can be confusing. The other capability is Python. You can use MicroPython to program Arduinos. But if you Google Arduino, you'll find thousands and thousands of articles. It's a very popular subject. So, you know, controlling these devices is very easy.
Yes, I also want to add that we can use like Delphi application as a client and use a lot of Azure and AWS services, which can implement IoT servers, and we can freely work with them without any problems.
Yeah, and in fact, I don't normally talk about my day job in webinars, but I'm going to briefly talk about some of the things I do in my day job. I actually work every single day with IoT devices, and the type of devices I work with are things like these. So these are fingerprint scanners, face recognition scanners, RFID, which is a bit like those Bluetooth tags, except it's not, it's a different technology, hand scanners, palm scanners, and Wi-Fi, I don't know, there's some option that they have, but these actually use two forms of technology. One is an SDK, and that is just an ActiveX control, actually, weirdly enough, that you can include, or a DLL, I think it's a DLL. So you just use that like you would any other external DLL, and you can communicate with it. But it also has the capability of using a cloud-based central server, and you can communicate with these devices using REST technology. And as we all know, hopefully by now, that RADStudio is a very good REST debugger built in, and actually creating REST apps is very, very easy in Delphi. You know, it's literally a couple of clicks and off you go. But all of these devices here, these are real world examples of IoT devices that are sold in their thousands. I know because the people that I write this for, you know, it's what their business is, and I've worked for them on and off for 25 years. So, yeah, it's been around a long time. In fact, this particular company were the first company in the UK to sell fingerprint scanners, long before anybody else had. They came across a company in CBIT, and we became the exclusive distributors, and I wrote the code for that. So, you know, if you think they're toys, IoT devices are not toys. They're being used in every single house you come across. There's probably an IoT device there. In Texas, there's a big problem with water, as you can understand. I'm going to stop sharing now, and we'll go back to my camera. In Texas, as you know, there's a big problem with water shortages and things like that. So we have a lot of sensors in our garages for whether our sprinklers are on and off and things like that, because it's so dry in Texas. It's not a desert here, but it's very dry. It doesn't rain very often, although ironically it's raining now. And the control of the water is quite important, because if you use too much water, then obviously you cause even more of a drought. We're always in a drought. But if you don't use enough, then all your plants die. And also the foundations of your house, because Texas houses are built on clay, those foundations crack and dry out. So that's an example of a practical device. Those, I've looked at them, and they're basically using modified Arduinos. So I know I could fiddle them to make them work differently, but I try not to touch these things, you know, because I don't want to break something and then get sued for it. But these kind of devices, you know, they're great. Not very expensive, really, even for someone in a country where the economy is much more not quite as buoyant, should we say, as the United States or the UK, but it's a lot of fun. So I think we've overshot our hour.
Yeah.
Target, which is always.
But we covered almost everything, because we cannot be too deep here into technology, because even one thing like MQTT, if we just take only MQTT, it can take a couple of hours, because it's not like 1 hour session, because but our goal was just show the possibilities that everything is possible, and the Delphi is on the edge of all these technologies. And
and I mean, we're bound to say that Delphi is the answer, because both of us are big fans of Delphi. But the thing is, it's true. You know, I am not a hypocrite. wouldn't go and say I liked something if I didn't. And also my reputation lies on me being, rests on me being able to talk about Delphi practically and show people practical examples of what you can and can't do with Delphi, and I do it all the time. And I'm able to program in C, C#, Python, C++, COBOL. Oh yeah, I'm that old. I actually predate Windows by quite a lot. I've been a programmer for 38 years.
Maybe also Fortran.
Yeah. Oh, Fortran's the only one I can't do, actually. And Algo. I programmed in Forth and a few other weird languages. But it's not because I'm stuck working with Delphi. It's not because that's the only language I know. It's just the only language I know where if someone's paying me to do something, I can do it. I definitely can do it in Delphi. And every time I've tried to use another technology, it either takes a lot longer, it's a lot harder, or I can't do it because, it hasn't got the things in there. Delphi has some areas where there are some other solutions that are better, but they're very narrow. It's not the case for most solutions. Delphi is the answer for nearly every problem anybody could have. And certainly with Internet of Things, you can have your little Delphi app running on a USB memory stick. It doesn't need to be installed. Most of these Delphi apps need no dependencies whatsoever, unlike a .NET app or Python app or anything else where you would need to install Python, you need to install the .NET runtime, big downloads. With a Delphi program, stick it on a USB memory stick, put it in the computer and run it. It will run immediately, and no installation required. You could have it talking to the device. So if you had a Internet Things device somewhere, you were on holiday on the beach. If you're lucky enough to get to the beach, I'd never get on the holiday. You could have a laptop, plug in this USB memory stick in some computer somewhere, and if it's got your Internet of Things program on it, it will run. Yeah. There's no other system that is that effective, I think.
That's called native application.
Correct. Yes, exactly right. And of course, everything we've shown you today will work on your mobile phone. So, it will actually work on a cell phone like this. Whoops, it thinks I'm trying to pay you. It will work on an Android device like this. I've got iPhones and things like that. The app that I showed you with the little messages coming through from the MQTT server, the little device here, that's a FireMonkey app, so I could have recompiled it and put it on my Android phone and it would work. Yeah, it's pretty cool, really.
Okay, I suggest finish on this positive note. This our session. Yeah, I think that's not our last event with Ian. Maybe guys, you will see something new very soon.
I guarantee it.
Yes. Thank you, Ian.
Well, thanks for having me as well.
I think for such a useful session, because with real examples and the code. Guys, if you will have any questions, you know how to reach us. To comments in the YouTube. I think that you can find Ian, me. If you want to ask something, you're welcome. Thank you.
Thanks a lot.
Ian, do you have some like the final words?
No, I think I've said all the words.
Great, yeah, I also think so. Thank you very much. Thank you, everybody. Bye-bye. See you on our next sessions.